The double star 6-pulse rectifier consists of 2 star 3-pulse rectifiers feeding in parallel to the same load, which is the right-hand star and the left-hand star. If we look at the right-hand star, the voltages forming the output voltage is V1, V3, and V5, which is V1, V3, and V5. When we look at the left-hand star, then we see that the wave shapes are now V2, V4, and V6. So it is V2, V4, and V6. Now, since these two rectifiers are in parallel feeding the same load, the load will see the average of the two. So where they cross at 0.866 Vmax, they are exactly the same, and therefore the average value will also be exactly the same. When we go to the point where the one is Vmax and the other one is 0.5 Vmax, the average will be 1 plus 0.5 divided by 2 gives us 0.75 Vmax. And that is happening there, 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 and there. In order now to see the wave shape over the load, we must join the dots. And when we join the dots, we get this pulse ripple voltage over the load. And that now is V load. And this one here is V left hand, and this green one here is V right hand. So that there is our load voltage. If we go look at the interphase reactor, we see that the interphase reactor VR is the difference between the left-hand output and the right-hand output. So the left-hand output is this one here, and the right-hand output is that one there. So at this point here, both are 0.866. If I subtract them from each other, I get 0. Then the left hand becomes Vmax, and the right hand becomes 0.5. 1 minus 0.5 gives me 0.5. Then at that point, we're back at 0. At this point, we now have 0.5 minus 1, which gives us minus 0.5 Vmax. And back at 0, back at the load voltage there, back at 0, etc. And now we join the dots to see the big picture. And we see that the reactor voltage VR is now a triangular waveform at 3 times the frequency of the supply. Thank you.